Okay, this is a motion problem. It says a particle moves along the x-axis, so that its velocity is given by a differential function v. So this is your velocity graph. It tells you that at t equals 0, t equals 3, t equals 5, you have a horizontal, at the velocity is 0, it tells you that you have horizontal tangents at t equals 1 and t equals 4, and at time t equals 0, the particle is at x equals -2. Okay. Part A, find both the time and the position of the particle when the particle is furthest to the left. So basically, this is asking you to find, when you're talking about furthest to the left, this is asking you to find the minimum of v of t. Okay, so how do we find, it's really asking for the absolute min. So how do we find the absolute min of anything? We need to check the derivatives, the critical numbers. So where is the derivative equal to 0? If I look at the graph, my possibilities are 3 and 5, but I know that 5 cannot be a min because the sign of the velocity goes from positive to negative, so 5 is a max. So that can't be a minimum anyway, since I'm looking for the absolute min. The only other possibilities are your endpoints, right? Anytime they're asking you to find absolute min, check your critical numbers, your endpoints. So these are my possibilities. How do I find the absolute min, the minimum position? I'm sorry, it's not where velocity is equal to 0. I want the minimum of position. So I want where the velocity is equal to 0, not the derivative velocity. So what I'm going to do is find the position at these 3 points, either at x of 0, x of 3, and x of 6, since these are my only possibilities. They told us in the original problem that the position was 2 at x of 0. X of 3, how do I find the position at 3? I need to integrate the velocity from 0 to 3, but remember we talked about you need to add on the initial condition, which is -2. This, they told you the area is 8, but because the graph is below the x-axis, the integral is -8, so this is really -8 plus -2, which is -10. Okay, x of 6, we're going to do it the exact same way. So if you want, we can take the -2, add the -10, and then we're going to add on the 3 and the -2. So this is +3, this is -2. I'm going to just go ahead and accumulate those areas. And this is -9. So -10 is obviously the absolute min, and it occurs at time t equals 3. This is a 3-point question. Next piece, for how many values is the particle at x equals -8? So basically we need to consider all the places where it's changing direction. So I'm going to come up with the position at 0, the position at 3, which we already came up with before, and the position at 5, because notice it is changing directions there, so I want to consider that possibility, and then the position at 6. Now, this is a differentiable function, so this position is also a continuous function. So the position of this object goes from -2 to -10, then -10 to -7, and then -7 to -9. I want to know when is it going to hit -8. So I know somewhere between here and here, because this is a continuous function, the y value goes from -2 to -10, so it's got to hit -8 at least once there. It also has to hit -8 once there. It also has to hit -8 once there as well. So it is going to be at least 3 times it has to hit a value of x equals -8, and it's because this is a continuous function. And this is really your intermediate value theorem that they're talking about here. It's 3 points here for showing that you considered all these possibilities, and then your answer 3 times, show them that you understand because it's continuous or using the intermediate value theorem. Okay. Next question, is the speed of the particle increasing or decreasing? When you think about speed, you need to be looking at the sign of the velocity and acceleration. Okay? From 2 to 3, I know that the velocity is negative just from looking at the graph. You don't have to justify it. They see that you have the graph there. Now, they don't give you the acceleration graph, but I do know that the slope of the velocity is your acceleration, so you need to justify using your velocity graph because that's what's given. So I know that the velocity is increasing from 2 to 3. So which really means that the second derivative is concave up. So if the signs are the same, we're going to say signs are opposite, speed is decreasing. This is just a 1-point question. Okay, last question. When is the acceleration negative? Okay, acceleration is negative. Make the connection between acceleration is the same as the slope of the velocity. When does this happen? I'm looking for where the velocity is decreasing. Justification is that the velocity is decreasing. You always justify with what is given. So 2 points, 1 point for the answer, 1 point for the justification. You can also say the slope of the velocity is negative. Your justification just has to come from the information given, which is the velocity graph.